This video is covering 7F, factoring by grouping. Specifically, I'm teaching what's called the reverse box method, just because we learned the box method with multiplication. So unmultiplying, factoring, is easier to learn going the other way around. Make sure to check your announcements so that you know your due dates and deadlines that are coming up. I have here our procedure for how to do the reverse box method. Okay, the biggest key feature here is to factor out any GCF. Okay, if you have a GCF, it will mess you up, which you will discover in the last two questions on this video. All right, so now here I have a four-term polynomial. Factoring a polynomial with 4 terms is just like factoring with 3 terms, just a little easier. So I'm going to set up my box. I'm putting the terms in the box. It's easiest when you put the terms in just to make the exponents count down as you go to the right and count down as you go down. So now looking for what I can take out of the box. Okay. If I start here, I see that I have an x squared that could come out of both those terms. My GCF here, if I have a 2 and a 14, the largest number I could take out is a 2. And now I'm going to do it with the columns. So here, the biggest thing I could divide out is an x. And in my right-hand column, the biggest expression I could divide out is a 7. All right, so I've found the GCFs of all the columns of the box. And so to put it in factored form, you just take the items that you put on the side and the items that you put on the top and give them their own separate parentheses. Make sure if something's positive that it has plus signs. If it's negative, it has a negative sign. And it doesn't really matter what order you put this in. So for example, say I put it in this order. It's kind of a potato-potato situation. It doesn't really matter because multiplication is what's called commutative. So it doesn't matter what order you multiply in as long as you're multiplying the two same terms. All right, trying it again. So again, this is a 4-term polynomial, so I don't need to do anything extra special for the reverse box here. All right, so I'm going to put my 3x cubed, my negative 3x squared there. You can kind of see a little bit of number patterning here, right? A little bit of foreshadowing, right? These are both 3s, these are both 1s. Hopefully, as you're kind of practicing stuff, you'll start to see some of these patterns. Do you recognize how it's alternating signs? Okay, that means you're going to have some negatives in here. So looking up top, I see a 3 that's common, as well as an x squared. Looking down below, x and negative 1 don't have anything in common. So their GCF is just a 1. And now I'm doing the columns here. So between 3x cubed and x, there's just an x. And here, my leading term, so the term with the highest exponent, is negative. So that means I'm going to divide out a negative in my GCF here. In fact, it's just a negative 1. So my final factored form is 3x squared plus 1 times x minus 1. You have to write it in factored form. Okay, showing the box is showing your work, but the factored form is the answer. Now for these problems, I went ahead and I set myself up with my factor tree just so that you don't have to watch me doing it in the video. But I want to talk about where that t-chart comes from here in just a second. Okay, this has 3 terms. It's not any different with the box. It's still a 2x2 box. Now I know the 3n squared can go in here, and I know the 4 can go in here. But if you think about when we're multiplying using the box method, right, we usually get this kind of diagonal that has these like terms that we combine. So what we have to do as mathematicians is decombine the like terms that make that negative 8n. And I do so with this t-table. So this left-hand side is a times c. So your first number times your last number. So 3 times 4. Now, I keep it positive when I do this because I don't like dealing with any negatives if there's like a negative here. I deal with those later on, okay? So if this was like a -4, I would still just find it for 12 because I'm too lazy to have to think about like adding and subtracting negative numbers. And so these are all the factors of that 12, all right? 1 and 12, 2 and 12, or 2 and 6, 3 and 4. You just divide using a calculator until this end and this end kind of flip, okay? Now this second sign that's here, I call that the choice sign. The choice sign tells me whether I should be adding or subtracting to find the terms that I'm decombining with. In this case, that choice sign's a plus, so I'm adding. So the two values here that add to make 8, I have 13, 8, and 7. That gives me 6 and 2 here. So that -8n, I'm going to call it a 6n and a 2n. Now here's where I consider the signs, right? To get a -8n by using a 6n and a 2n, these would both have to be negative, right? Your choice sign, by the way, gives you the hint that these have to be matching, either both positive or both negative. If your choice sign was a negative, these would be opposite signs of each other. All right, so now your box is set up. We could just do the same thing. All right, so I'm going to start with my rows. Here I see a 3n I could divide out. Down below, my leading term is negative, so I'm going to take out a -2. Now when I go to do my columns here, this one only has an n in common. In this one, the leading term's negative, so I'm taking out a negative. And between 6n and 4, I could take out a 2. So my factored form is 3n minus 2 times n minus 2. A lot of you guys probably can do this pretty implicitly. Like by that third example, this is probably pretty simple for you. Hopefully at some point you can pause this video and try it on your own. See if you can do it, you know what I mean? So on this one, I could put my a term and my c term in the box. Now a times c, 6 times 1 is 6. And these are my factors of 6. My choice sign is a plus, so I'm adding to make 5 here, which would be 3 and 2 here. So I'm going to call it a 3x and a 2x. And I think about my signs. To get a positive 5x, these both have to be positive terms. All right, so now I'm taking my GCFs. So between 6x squared and 3x, I could divide out a 3x. Between 2x and 1, I could divide out a 1. And now I'm coming this way, okay? I see a 2x that I could divide out of that column and a 1 that I could divide out of that column. So altogether, I have 3x plus 1 times 2x plus 1. All right, let's try it again. So here's my 2x2 box. Ooh, it didn't snap to make it nice. I'm going to have a 2n squared and a 2, right, because my a and c term fall in. My choice sign, again, is a plus, so I'm adding to make 5. So it'll be this set here with the 4 and the 1. So my 5n decombines into 4n and 1n. And those both have to be positive to make a positive 5. So now checking out my rows here, right? The top row, I could take out a 2n from each one. In my bottom row, they just have a 1 in common. Now I'm doing my columns. So between 2n squared and n, I have an n. Between 4n and 2, I have a 2. Now the nice thing about factoring is it has a kind of built-in check step. You can multiply these back out and see if it works. All right, here's another one. This one, notice we're changing some of the signs a little bit now. On this one, our choice sign's a negative on it, so that's going to be really interesting to see. All right, so my a times c is 18. And my choice sign, again, is that negative that's here in front of the 9. So I'm subtracting to make 3. So the two numbers that multiply to make 18, that subtract to make 3, are 6 and 3. So I'm going to call it a 6n and a 3n. Now, this is a positive 3n, so I know the bigger number out of these two has to be positive. I often call that the fall down sign because it falls to the bigger number. But to get a 3n as my output, this 3n has to be negative so that when they combine, 6 minus 3 makes that 3. And that's just the same old goodness. Okay, so going across my my rows, 2n squared and 6n has a 2n in common. Okay, my bottom row has a leading negative, so I'm going to put a negative here. And 3 and 9 have a 3 in common. Now I'm doing my columns. This one only has an n in common. And this one only has a 3 in common. So my final factored form is 2n minus 3 and n plus 3. Now this one should look pretty simple, right? My a value is a 1. In a later video, I'm going to show you a method called the double bubble method, which is what you do when your a value is 1. It makes things a lot easier. Now my choice sign here is negative, okay? So there's a 1 here. 1 times 80 is 80. And I'm subtracting to make the 2 that's here. Subtracting to make that b value. In this case, it would be the 10 and the 8 that make that. So I know I'm going to have a 10x and an 8x. Now my fall down sign's a minus, so this 10 has to be negative. And a negative plus 8 is what makes that a negative 2 here. You know these have to be opposite signs also because of your choice sign being a negative. All right, so going across my columns, these just have an x in common, and these have an 8 in common. So I'm going to call that x and 8. I keep calling those columns, and I mean rows. Now going for the real columns, okay, this first column has an x in common. This one, the leading term is negative, so it has to be a negative, and 10 and 80 have a 10 in common. All right. Okay. So I'm going to write this out because I know some of you guys aren't listening to this video, so I'm saying, warning, wait to write this down. I'm going to show you what happens if you don't take out the GCF. All right, when you go to take out the GCF, okay, these are huge numbers for one thing, right? 6 and 42 is going to be bananas to try to find the factors of. Let's see. Should have planned better. So I'm looking for what multiplies to make 252 that subtracts to make 4. Holy macaronis. Let's see, if I divide by 42 and 6 gives me 36. So I know it has to be bigger than 6. 36 and 7. Again, it's getting closer. It's what, 29? 18 and 14 subtracts to make the 4. So I could call this 18y and negative 14y. Now I want you to see what happens here. So when I go to take my GCFs out, okay, this would turn into a 6y. And in this column, the GCF would be 2y. Now that's an issue, isn't it? Because 6y times 2y does not make 6y squared. And so that's why you have to take the GCF out, because otherwise your box won't won't quite add up the way that you need it to. Okay, so now we're going to commence. We're going to take out our GCF first. So my GCF, the thing I could take out of all of these terms, is a 2 because they are all even. Okay, so that gives me a 3y squared plus 2y minus 21. And that's what I'm going to box method here. Now, it's worth pointing out, when I divide my GCF out, well, 3 times 21 is only 63. So that's actually a lot smaller for you to have to find the factors list of. It's way less intimidating than it was, which is really nice. Now, the ones that subtract to make 2 are 9 and 7. The 9 has to be positive, which means the 7 has to be negative, right? Because your choice sign's negative. These have to have opposite signs. All right, so now I'm going for my GCFs, right? This has a 3y, a negative 7, a y, and a 3. Now, the only thing when you take out your GCF is he kind of hangs around. He's like a little puppy, okay? So this GCF, he has to come, boop, 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 hang out here. Because if I multiply the 3y minus 7 and the y plus 3 back together, it wouldn't end up with the original term. It would end up at that term, which you then have to double to get to the original kind of polynomial. So make sure if you factor a GCF out that your final answer has the GCF hanging out in front. One more time. These are all divisible by 5 because they end in 5 or 0. So I'm going to divide a 5 out. Okay, when I do that, I get 2k squared minus 15k plus 13. Okay, so setting up my box here, a times c, 2 times 13, is the 26 that I have here. All right, so my choice sign is adding. So I'm finding what adds to make 15, which in this case is the 13 and the 2. Now my fall down sign's a negative, so I know that 13k has to be negative. And because my choice sign is positive, these guys have to match, so the 2k is also going to be negative. All right, looking out for those GCFs. Hopefully by now, the GCF is really easy for you to find. Like, I'm hoping that, you know, it's pretty straightforward because you've covered it on just GCF, and then we covered it here in the box. And then remember that GCF that we took out comes and hangs out in front. And there we have it, y'all. That is officially how to use the reverse box method.